Okay. What up, Hazelton from 403 to the HAZ? Yeah, tagline. It's better than, hi guys, welcome to my YouTube channel. Please subscribe down there. It's Monday morning, I'm a little loopy. Deal with it. Okay. So far we've actually covered a lot. So we've talked about prime factorization, we've worked with exponents and radicals and learned how exponents add and multiply together, all these things. So now, and we've also learned about multiplying polynomials and binomials, so all that stuff. Now we're going to bring it all together and start talking about the reverse of multiplying polynomials, which is factoring them. And in order to factor polynomials, we have to know how to factor both variables, so things like x squared, y cubed, as well as factoring our prime factoring just regular numbers. So we recall that if we were to factor a number like 10, we just have to bring it down to its prime factors. So 2 is a prime factor, 5. So that's factor 10, 2 and 5. If I were to do 20, I could do it 20 divided by 2, 10, and then 10 gives me 2 and 5. Okay, so 10 is the same as 2 times 5. 20 is the same as 2 times 2 times 5. Okay, now we can do the same process with variables, and it's actually a lot easier, more straightforward. So say I had x squared. Well, x squared's factors are x and x, because x times x is x1 plus 1 is 2. So I could write x squared is equal to x times x. If I had something like x squared, y squared, I could factor this as, okay, well this is going to give me x and x, and this is going to give me y and y. So then this factored would just look like it's x times y times y. X times x is x1 plus 1 is x squared, times y is y1 plus 1, because remember when we multiply when we multiply variables like this, that's probably not the right word, but we have to add their exponents. So then the next step, so let's do one more just to drive it home. If I had x cubed, y squared, z, this factored, you guessed it, would look like this. X times x times x times y times z. That's the factored version of that expression. So we need to combine now. If we're going to, phase one of factoring is we're going to start with factoring binomials, and then we're going to move on to factoring polynomials. And step one is just kind of doing this prime factorization approach, where we just pull out whatever we can. So what does that look like? So let's say I give you something like, we're going to start with binomials, okay? So we'll start with binomials, which is just expressions with 2 variables in it, separated by 1 addition or subtraction. So binomials are like 2n plus 2, or 3x plus 4y. These are all binomials, there's just 2. A trinomial, 3, would be something like 2n squared plus 3n plus 2. That's a trinomial. We'll start with binomials, okay? So say I told you to factor something like 3n plus 9, okay? So the first step to do something like this is to look at each individual number. Okay, so 3n. The 3 is a prime number, so it cannot be factored any lower, okay? And then the n, it can't be factored any lower. So I have 3 and I have n in this 3n. And then on the 9, so I can write 3n as 3 times n. The 9 factors down to 2 prime 3's. So 9 is therefore equal to 3 times 3. So now, the next step, once I've broken each down into their factors, is I find whatever numbers they have in common. So the only things these have in common is each has 1 3. So that means that I'm actually going to, this becomes, I pull out a 3. I pull out a 3, because they both have a 3 in common. And then I look, okay, then I open a bracket, and I say 3 times what gives me 3n? Well, 3 times n gives me 3n. Okay? Right there. And then 3 times what gives me plus 9? Well, 3 times 3 gives me plus 9. And I have factored. This is my factored binomial. Okay, so let's do another example. Let's say I had, with binomials, let's say I had 5s squared plus 25s. Okay, so first I start with the 5s. An s squared. So the 5 is already prime, so it's already factored. The s is made up of 2 s's multiplied together. So 5s squared can be written as 5 times s times s. Okay? And then the 25s, 25 and s, well, the 25 factors to 5 and a 5, and the s is already factored. So 25s becomes 5 times 5 times s. And then I look at these two and I say, okay, what factors do they have in common? Well, they each have a 5 and they each have an s. So that means that I can pull out a 5s. So I say, okay, 5s, bracket, 5s times what gives me 5s squared? Well, it's right there. So I put the s there, and then there's an addition sign, and then 5s times what gives me 25s? Well, it's right there, the one left over, plus 5. So the factored version of 5s squared plus 25s is 5s, s plus 5. That is factored. That's what it looks like. Okay, let's do a couple more examples here. Okay, so we'll do one more binomial, and then we'll jump into a trinomial. Oh, I got a good one for you here. Got a good one. Okay, so let's try 6c to the power of 4 plus 24c squared. Okay, let's factor this. So start with the 6c. So we have 6 and we have c. 6 factors down to a 3 and a 2. C to the power 4 factors down to, you guessed it, 4 c's. C times c times c times c gives me c to the power of 4. So each of these is circled, those are ends. So then we get 6c to the power of 4 is equal to 3 times 2 times c times c times c times c. Okay? That's the factors of 6c to the power of 4. And then I do the same thing with the 24 here. So 24 and c squared. So 24 gives me 2 and 12. Not done. 12 gives me 4 and 3. And 4 gives me 2 and 2. 2 times 2 is 4 times 2 is 8 times 3 is 24. So that's that. And then the c squared is c times c. So I write that over here. So 24c squared is 2 times 2 times 2. So it's 3 times 2 times 2 times 2 times c times c. Okay, so what do these two have in common? Well, you can clearly see they both have a 3 times 2. So we'll be pulling out a 3 times 2. And they also have 2 c's. common. This one has 4, this one has 2. So they have 2 in common. So I can pull out 3 times 2 and 2c. So I can do this. So I write, this is equal to 3 times 2 times c times, open bracket, whatever's left here, c times c. So c times c is c squared, and I'm going to do that here too. This is c squared. There's 2 c's multiplied together, c squared. So they're multiplying by the 2 c's here to get to that guy, and then there's 2 times 2, which is 4, so plus 4 over here. And then if I 3 times 2 is 6, so I have 6c squared multiplied by c squared plus 4. That is my factored product. Now I can check to make sure that this is right by going through and multiplying, like I've learned how to do, multiplying binomials. So 6c times c squared is 6c, 2 plus 2, which is 4, plus 6 times 4 is 24, and times c squared. So this is 6c to the power of 4 plus 24c squared. That is right. So this is the correct answer here. This is correct, okay? So let's move into polynomials, more than 2 terms. And it's going to be the exact same approach, just more numbers to keep track of. So let's say I have something like, on to polynomials now. So let's say I have 12 x cubed y minus 20 x squared y squared plus 16 x cubed y squared. Okay, so now I have to do factor trees for all 3 of these. So let's start with 12. Got 12 x cubed y. So 12 factors down to a 2 and a 6, and then a 2 and a 3. X cubed is just, so the x cubed is 3 x's, and then y is just y. Okay, so 12 x cubed y factors into 2 times 2 times 3, so 2 times 2 times 3 times x times x times x times y. Okay, next part here, we've got 20 x squared y squared. I'm just spreading them out so that I can have space to do my factor tree. So this is 2 and 10. 10 factors to 2 and 5. This factors into 2 x's, and this factors into 2 y's. Y times y is y squared, x times x is x squared. So now I can write that in my factor tree here. So 20 x squared y squared is equal to 2 times 2 times 5 times x times y times y. And finally, the last term, I've got 16 x cubed y squared. 16 factors into 2 and 8, into 4, into 4 and 2, and then into 2 and 2. X cubed is into 3 x's. And then y squared is into y and y. So I get 16 x cubed y squared is equal to 2 times 2 times 2 times 2 times x times x times x times y times y. Now I got 3 items here with 3 factors here. factor trees. Now I have to find what I have in common. So let's start with just the digits, the numbers, the non-variables. In common here, across all three, I have two sets of 2's in common. Those are the only things that I have in common. In terms of x, I have two sets of x in common. And then in terms of y, I have one y in common. So I can pull out 2 times 2 is 4, x times x is x squared, y. So I can pull out 4 x squared y. And then I open my bracket. For this term, I'm going to have 3x here left over. So 3x. 4 times 3 is 12. X squared times x is x cubed. Y times nothing is y, or y times 1 is y. So it's 3x. Then I have a negative sign. And then I have left over, I have a 5 and a y. So minus 5y. And then 4 times 5 is negative 20. X times 1 is x squared, so x squared. And then y times y is y squared. So this will be negative 20 x squared y squared. And then plus 2 times 2 is 4. And then x times y, so xy. And then so 4 times 4 is 16. X squared times x is x cubed. And then y times y is y squared. So this is the factored version of this. And that's how we factor. So we will probably be doing more problems in the future, but this is it right here. Mr. Nelson, one more? Okay, I'll do one more example for you. Sure. Since you asked so politely. Okay, so let's do one more example. So let's say I had 3p squared q, sure, plus 9p cubed q squared plus 27 PQ. Okay, so I start with each one. So I look at my first term here. So I have 3 p squared q. 3 is already primed. P is 2 p's. Q is already primed. So 3p squared q factors down to 3 times p times p times q. One down. The next one. 9p cubed q squared. So 9 factors down to 2 3's. P cubed factors into 3 p's. And q squared factors into 2 q's. So that then 9p cubed q squared is 3 times 3 times p times p times p times q times q. And then 27pq. 27 factors down into a 3 and a 9, which then factors into 2 3's. P is already primed, Q is already primed. They can't be factored any lower. So then 27 PQ is equal to 3 times 3 times 3 times P times Q. Okay? And now I look at my factor trees for all 3 terms in my trinomial. And I can see that I have 1 3 in common across all 3. I have 1p in common across all 3, and I have 1q in common across all 3. So I can pull out 3pq, 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 3pq. So I pull out 3pq, and then I open my bracket. It's going to be times p in the first one. Whatever's left is my p. So 3pq times p is 3p squared q, which is what it should be, plus 2p's p squared q, so plus 3p squared q, 3 times 3 is 9. P times p squared is p cubed. Q times q is q squared. And then plus 3 times 3 is 9, so plus 9. That's all that is. So 3 times 9 is 27, p cubed is left. So this is the fun. And then yeah, you can formally go through and multiply the binomial in front by each in the trinomial here and figure out what we get, and we would get this answer. So that's phase 1 of factoring. That's kind of like the baseline, and that's where we're going to build from. So thanks for watching. Hey.